Uncertainties part 1. So this is A-level physics. Okay, this is A-level physics. So the first rule in uncertainties, if you're adding or subtracting variables with the uncertainties, you just add the uncertainties. Okay, so whether you're adding or subtracting variables with uncertainties, you just add the uncertainties. Okay, so that's why this rule is saying that the uncertainty in u is equal to plus or minus the uncertainty in x plus the uncertainty in y, in both cases, in addition or subtraction. So I have two questions here, and so I'm going to two questions are so quickly, then you're done. And so obviously, if you're A level, you know you've already done this. Okay, so to go over two questions, question 1, question 2, then we'll be done. So question one is saying that the internal diameter d1 and the external diameter d2 of a metal tube are d1, okay, d1 with 45 millimeters plus or minus 1 millimeter, right, and also d2 with 60 millimeters plus or minus 2 millimeters, right. So plus or minus 2 millimeter is the uncertainty in d2, plus or minus 1 millimeter is the uncertainty in d1. So the question is now saying now, what is the percentage uncertainty in the thickness of the tube? Okay, so how do we find the thickness of the tube? Okay, so it's very simple to find the thickness of a tube. The thickness of a tube is the external diameter minus the internal diameter. Okay, external diameter minus internal diameter, that's the thickness of the tube, right? So the question here is focused on the uncertainty, right? Because the internal diameter d1 is plus or minus 1 millimeter, and d2, the external diameter, is plus or minus what? 2 millimeters. So what does the rule say? The rule say whether you're adding or subtracting, you just add the uncertainties. It's mentioned here, right? The uncertainty in u is equal to the plus or minus uncertainty in x plus the uncertainty in y. Therefore, we are going to subtract 60 minus 45. Okay, 60 minus 45, we get 15 millimeters, right? That's the thickness of the tube, right? But we are adding the uncertainties now. We are adding 1 and 2, right? The uncertainty in d1 plus the uncertainty in d2. So it will be 15 plus or minus 3 millimeters. So the solution for question 1 is very simple, right? 15 plus or minus 3 millimeters. This is the thickness of the tube. That's the thickness of the tube. You're done with physics. What is the question in physics, right? So now we want to move on to question 2 now. We want to move on to question 2. In question 2 is saying that the external and internal diameter d1 and d2 respectively are measured is 64, okay, 64 plus or minus 2 millimeters, and 67 plus or minus 1 millimeter, right? And the question now continues to say, what is the percentage uncertainty in d1 minus d2, right? Okay, so the percentage uncertainty in d1 minus d2. So I'm going to take a blank page, then we calculate the question now. Okay, so I've just done question 2 on a separate answer sheet for working purposes, right? So d1 is equal to 64 plus or minus 2 millimeters. Okay, so 2 is the absolute error with the uncertainty in d1, and d2 is equal to 47 plus or minus 1 millimeter, which is the absolute error in d2, or we can say the uncertainty in d2. So the question is saying that what is the percentage uncertainty in d1 minus d2, right? This is very, very simple, right? So what does the formula say? The absolute error in u is going to be equal to plus or minus the absolute error in x plus the absolute error in y, right? Or we can say that the uncertainty in u is equal to the plus or minus the uncertainty in x plus the uncertainty in y. It's the same thing, okay? It's the absolute error, a good uncertainty, just means the same thing, right? So what is d1 minus d2? So d1 minus d2 is going to be equal to 64 minus 47, which is equal to 17, right? Plus or minus the absolute error. The absolute error in d1 minus d2, I've mentioned this earlier. Whether you're adding or subtracting, you just add the uncertainties or absolute error. The absolute error in d1 is 2. The absolute error in d2 is 1, right? So we add in whatever case, whether you're adding the variables or you're subtracting. Whether we were adding d1 and d2 or we were subtracting d1 and d2 like we are, right now. The absolute errors were just going to be added in both cases, right? So okay, so the absolute error in D1 is 2, the absolute error in D2 is 1. So if we add 1 and 2, we get 3. So the absolute error in D1 minus D2 is going to be equal to 17 plus or minus 3 millimeters, right? So the percentage error, this is the formula now for the percentage error, right? So the percentage error, you calculate it like this. The absolute error in U over U times 100 is going to be equal to the percentage error, is equal to the percentage error, is equal to the percentage error. Then you're done with physics, you're done with uncertainties, right? So what is the absolute error in U? In this case, we are calculating the absolute error, the percentage error in D1 minus D2, right? So what is the absolute error in D1 minus D2? The absolute error in D1 minus 2 is 3, right? It's 3. And what is D1 minus D2? So which means if you translate this formula to suit our situation or to suit our question, it will be the absolute error in bracket D1 minus D2 bracket over D1 minus D2 times 100 is our percentage error. The absolute error in D1 minus D2, what is the absolute error in D1 minus D2? Which is 3. This is the absolute error in D1 minus D2, which is 3. 3 over D1 minus 2 is going to be equal to what? 17 over 17 times 100. This is grade 7 mathematics. You're done. That would be times 100. That would be the absolute error in D1 minus D2. Then you're done.